Dr. Neha Singh, Assistant Professor in Computer Science Engineering Department from Ajay Kumar Engineering College. Today we discuss the topic regression modeling, concept learning and support vector machine. First we know what is a regression modeling. So regression modeling is a statistical method technique which is used to show the relationship between dependent and independent variables. So dependent variable and independent variable means, for example, number of student score based on the study hours. So in this example, student score is dependent variable and the study hours, and study hours is the independent variable. So regression model is basically a predictive modeling technique which show the relationship between dependent and independent variable, which is this technique used for basically forecasting, time series modeling and finding the causal effect relationship between the variables. Causal effect relationship, which means show the error of the models. So for example, in regression modeling, in employee salary based on the year of experience, in which year of experience is a independent variable and salary is the dependent variable. In regression and regression models are widely used in a data analytics technique that is basically used for the identification of the data and show the relationship between the variables. And regression modeling show the continuous values such like temperature, age, salary, prices, and many more. And regression modeling is basically used for analyzing the data and for classification of data. So what is the benefits of regression modeling? So some of the benefits of regression modeling, like it shows the relationship between dependent and independent variables, and it indicates the strength of the impact multiple independent variable on a dependent variable. Next is uses of regression modeling. So it's used in real world scenario. Regression modeling used for the weather conditions, sales prediction, marketing, trends. So so many fields use in regression modeling. Next is types of regression modeling. So regression modeling is basically 8 types, but we learn in the linear and logistic regression. So first is a linear regression, second is a polynomial regression, third is a support vector machine, fourth is a decision tree, fifth is a random forest regression, sixth is rigged regression, seventh is lasso regression, and eighth is logistic regression. So in a linear regression, it shows the relationship between one dependent variable and one independent variable. Now next is a polynomial regression. Polynomial shows the degree of polynomial of the relationship, and it shows the curve-like structure. And third is a support vector regression. Support vector regression we basically use for the classification purpose, that classify the two classes, separate the two classes. Now next is a decision tree learning. Decision tree learning is a hierarchical tree-like structure that is used for the classification. Now next is a random forest regression. In random forest regression, give the multiple decision tree, and all the multiple decision tree output are combined in one place and then average result is produced. Next is a rigged regression. Rigged regression is also known as a L2 regression, and lasso regression is also known as a L1 regression. Both are used for the minimizing the errors. Logistic regression. Logistic regression is used to show the it used for a binary classification, that is true, false, yes, no, yeah, zero or 1 form, and it shows the structure in S curve form, and it also used the sigmoidal function, which equation is 1/1 plus e to the power minus x. So we discuss linear regression in detail. So linear regression are widely known modeling techniques, and in this technique, one is we use a one dependent variable and one is independent variable, and it shows in linear regression shows a continuous relationship like temperature, height, age, salary, etc. And linear regression, it shows the linear relationship between dependent and independent. It shows the dependent and independent relationship, shows the straight line, through the straight line. Linear regression, in linear regression, use the equation y equal to a plus b into x plus c, where a is the intercept, b is the slope, and e is the error term, and used to predict the target variable based on the given predict variables. Here the show the relationship between weight and height. So have the linear relationship through the straight line. Goal of the linear regression. So goal of the linear regression is used to find the best fit line of the relationship between the variables, and it also used for to calculate the sum of squared error and mean of squared error value. With sum of squared error and mean of squared error value is basically actual value of our target value to compute the errors. Next is the logistic regression. Logistic regression is another supervised machine learning algorithm which is used for classification purpose. In logistic regression, basically we classify the use the binary classification purpose like true, false, yes, no, or 0 on 1 values, and it shows the and the regression, and it also use the logistic regression is a sigmoidal function, and it's graph like x structure S curve curve form. So in logistic regression, use the linear regression model, but the logistic regression use the linear regression model is basically used for the simple data like x and y for predicting the data, but logistic regression basically used for the complex data classification, and it shows the relationship between 0 or 1 and true or false. So here the graph structure of logistic regression like S curve form, and use the function sigmoidal function 1 upon 1 plus e power minus z, or here the equation used for the logistic regression sigma of wj xi plus bias. Wi is the weight and xi is the input value. Basically logistic sigmoidal function used for the logistic regression. So fx is the output between 0 and n, x is the input function, e is the base of the natural logarithm. So next topic is the difference between the linear regression and logistic regression. So linear regression is used to show the linear relationship between dependent and independent variable, and a logistic regression predict the categorical dependent variable using the given set of independent variables. So logistic linear regression is used for the solving the regression problem, and logistic regression is used for the solving the classification problem. In linear regression, we predict the value of continuous value, and in the logistic regression, we use to predict the categorical variables. So in linear regression, we find the best fit line, and logistic regression, we find the S curve by which we can classify the sample of the data. So in linear regression, must classify the continuous values, and logistic regression classify the categorical value like 0, 1, yes or no, or true or false. So linear regression show the relationship between dependent and independent variable, and in logistic regression not require the linear relationship between the variables like dependent and independent variables. Now our next topic is the concept learning. So concept learning is basically a machine learning refers to the process of teaching a machine to learn or identify the pattern of the pattern or categorize the data. Like for example, if we show the machine to cat or dog picture images to learn the pattern of that animal pictures. So when we given the new data arrives, and then machine classify the this picture is dog or cat. So basically concept learning is the process of the teaching of machine to identify the pattern or categorizing the patterns or identify the patterns. So concept learning is a process basically of learning how to classify objects, events or data into the groups, and it's also known as the concept learning is also known as the category learning. So in concept learning, we also use the basal learning concepts. That is particularly useful where the uncertain data or noisy data are given. So now next is the types of concept learning. So basically concept learning classify in two parts: supervised learning and unsupervised learning, unsupervised concept learning. So in supervised learning, machine gives the label data, means already machine is known the target output, but it data target label. So the goal of machine is to learn the concept and identifying the pattern of that given data. So for example, if given the image of animals picture cat or dog, so machine learn the pattern of cat or dog, then when new images are arrived, then classify the image that is dog or cat. Now next is the unsupervised concept learning. In unsupervised concept learning is defined by the unlabeled data, where there is no if any data is given, there is no label, which means there is no tag are given. This is a cat and this is a dog. Machine identify itself to draw the pattern. Next is topic is how concept learning work. So concept learning is basically defined by the three parts: learning from example, hypothesis formation, and hypothesis space. So learning from examples, machine start by analyzing examples or data points. These examples could be labeled or unlabeled. From these examples, the machine tries to identify pattern and underlying concept. Now next is a hypothesis formation. So based on example provided or training data, the machine forms a hypothesis or general rule that explains the data. This hypothesis represents the concept that the machine learning is trying to learn. For example, a hypothesis might be if an image has fur and whisker, it is a cat. Now next is a hypothesis space. So machine explore different possible hypotheses to find the best one that fits the data. So this exploration happens within what's called the hypothesis space, which include all the possible rules or concept the machine could learn. So the goal is to find the hypothesis that best matches the training examples. Now next topic is how concept learning next is the generalization. So once hypothesis is chosen, the machine applies to the new unseen data. This process generalize allows the model to make the prediction about the data has not encountered before based on the concept it has learned. And next is refinement. During the learning process, the machine may need to refine its hypothesis as more data is introduced, and it might adjust its concepts to better match the new examples or correct any errors in initial learning. Next is the real world application of concept learning. So concept learning is used in various fields like healthcare. In healthcare, used for to classify the patient data and identify the pattern that suggests a specific illness or condition. For example, a model trained to recognize signs of phenomena in chest X-ray can help doctors to identify cases faster and with greater accuracy. Next is finance. In finance, concept learning is used to help the fraud detection transactions data by analyzing past financial data. Can learn the model pattern and identify the fraud transactions data. Now next is a retail. Machine learning, retailers use concept learning in recommendation system to suggest product to the customer based on their previous purchase and browsing behavior. Like Amazon recommends engine learns from your shopping history to suggest new products you might like. Next is the marketing and advertising. Concept learning basically used in the marketing and advertising field for predicting what type of content products user most like to engage with. Next is manufacturing. So concept learning helps in predictive maintenance, where machine can learn to identify signs of equipment failure before they occur. So in in all these field concept learning is used. So our next topic is a support vector machine. So support vector machine is a type of supervised learning algorithm which is used for the classification or regression both, but mostly used for the classification purpose. So support vector machine is basically used to separate the two classes when given the two classes, and it is separate two classes. So as we support vector machine goal is to create the best line or decision boundary that can segregate the two classes. The best decision line boundary is called the hyperplane. So in support vector, in this picture here the two classes are given. One is a circle class and one is a square class. So we separate the two classes are the straight line. Is this straight line is called the decision bound hyperplane, and dotted line is called the decision boundary. And the support vector is nearest point of the decision boundary is called the support vector. If in decision boundary maximum margin if maximum margin hyperplane, so support vector machine will give the best result. So some of the key concept of the support vector machine, first is the supervised learning. So support vector machine is the part of the supervised learning techniques. And hyperplane is used to separate the two classes. And support vector is the closest point of the decision boundary. It's called the support vector. So in margin, the margin is the distance between the hyperplane and the nearest data points from the either the class. Here the example of the support vector machine in supervised machine learning. In machine, give the data, pass label data, like one image is a cat and one is a dog. So model train the model is learn the model pattern and then predict this new data. New data is come to the machine to it's a cat. So SVM algorithm can be used basically for face detection, image classification and text categorization. So types of support vector machine. Support vector machine is basically two types: linear support vector machine and non-linear support vector machine. In linear support vector machine is used for linearly separable data, which means can be classified into two classes by using a single straight line. So in non-linear, SVM used for the non-linearly separated data, and it is not classified through the straight line. So application of SVM basically used for text classification, image recognition and bioinformatics. And advantage of support vector machine is effective in high dimensional data, robust to overfitting, versatile, clear margin and separation data, memory efficient. And disadvantage of the support vector machine is a computationally intensive, choice of kernel, sensitive to noise data, less effective with overlapping classes. Now next is the properties of SVM: maximum margin classification, support vectors, kernel tree sparsity, flexible in kernel choice. Issues in SVM: computational cost, parameter tuning, scalability issues, lack of probabilities output, sensitive to noisy data, interpretation difficulty. That's all. Thank you.